Hi guys, this is Evan. Welcome back. Today we're going to talk about Maxwell's demon. This is the third episode of our four great pieces of physics series. And before you click away, please stick with me for a few minutes. I promise this is going to be really interesting and I will speak quickly so I won't waste your time. So imagine that you've just made a hot cup of coffee, you set it on your desk, but after a while, it cools down to room temperature, right? Or think about a drink with ice cubes and ice melts, and soon enough, your drink is going to be cold water. So what's happening there? You might never think about that. You think it's quite natural. But behind that, there is one of the most fundamental principles of physics. It is the second law of thermodynamics. This law basically said that energy naturally spreads out, moving from hot areas to cooler areas until everything is balanced. And that's the everything about the entropy. So entropy is just like a way of talking about how much things have spread out or gotten disordered. So whether it's your coffee cooling down or your ice cubes melting, it's all about entropy increasing over time. But here's the thing. The idea of increasing entropy seems pretty unbreakable until we meet Maxwell's demon, which challenges this very concept. Alright, so now that we've got a grip on entropy and how entropy likes to spread out, let's talk about something really interesting. Maxwell's demon. Hmm, this little guy was dreamed up by the physicist James Clerk Maxwell back in the 19th century. Here's how it works. Imagine you have a box divided into two sections by a wall with a tiny door. On the one hand, there's the fast moving gas molecules. These are hot ones. On the other side, the molecules are slower and cooler. And now picture a tiny demon sitting at the door, watching the gas molecules zoom around. Every time a fast molecule hits towards the door, the demon quickly opens it and let that molecule pass into the hot side. And when a slow molecule comes along, the demon let it pass to the cold side. So over time, the hot side gets hotter and the cold side gets colder. But wait a minute, did we just say that the energy spread out and the entropy always increases? What's the demons doing here is seems to break that rule. It's creating order from chaos, making one side hotter and other sides colder without adding any extra energy. And that seems like a way to decrease entropy, which would totally challenge the second law of thermodynamics. So what's going on there? Is the demon really breaking one of the most fundamental laws of physics? Well, it sure seems that way, at least on the surface, but there's more to the story, and that's where the story gets more interesting. Alright, we've seen how this little demon seems to be pulling off something really incredible. But here's the thing. To do this job, this team has to know exactly which molecules are fast and which are slow. So it has to observe each molecule, make a decision, and then open or close the door. This means that this demon is actually processing a lot of information. It's like it's keeping track of all these tiny details in its head. But just like how our computers and phones needs to store and manage information, the daemon has to do the same. And this is where the Landauer's principles comes in. Landauer's principles is a rule in physics that says that every time you erase a bit of information, it will cost a tiny bit of energy. In other words, there is no free lunch when it comes to handling information. So even though the demon seems like it's lowering the entropy of the gas by sorting the molecules, it's actually paying the price. Every time this demon erases the old information and make a room for the new data, it releases the energy as heat. This heat increases the overall entropy of the system, balancing out the decrease caused by the sorting. In the end, when you take into account the demon's information processing, the total entropy of the system does not actually decrease. So why it look like this demon was breaking the rules? But physics makes sure that the second law still stands strong. So what does all this mean? Why should we care about a tiny demon that's playing tricks with gas molecules? Well, the Maxwell demon give us some pretty big insights into how the universe works. First, it reminds us that the laws of thermodynamics are pretty solid. They don't just break because something seems to bend the rules. Even when it looks like we found a way to cheat like with a demon, but there's always a catch. So the universe always has a way of balancing things out. You know, that's pretty interesting. Second, Maxwell's demons shows us just how connected the information and energy really are. This tiny thought experiment helped pave the way for understanding the cost of processing information, which is something that's super important today in computing and technology. So every time when we handle data, there must be an energy cost. Finally, this little demon teaches us a big lesson about curiosity and questioning the rules. By thinking about how things might not work, we can learn more about why they do work. So even though this demon didn't break the laws of physics, it helped us to understand them better. Okay, that's all that I want to share today. In next video, we will be tackling another mind-bending concept, Schrodinger's cat. And that's also the last episode of our 4 great bits of physics series. So don't forget to subscribe, like, and share with your friends. And see you in the next video. Bye bye.